Just to review, looking at an additive number system, the Egyptian number system is additive. I put down there a 10 and a 1. We know that number as 11. Now, if I just were to switch it and make it a 1 and a 10, it wouldn't matter. It's still 11. That's the fundamentals of an additive number system. The Babylonians are credited with the first place value system. It's based on place values of 60, powers of 60. The first 59 digits are listed there. If you want to write 60, you would write 1 in the 60th place. Or you would use the numeral they have for 1. But I'm just going to use the number 1. And 0 in the 1's place. So that number in Babylonian is 60. Notice how many numerals you had to memorize. Our base 10 system uses 0 through 9 as the digits. And it's base 10 because as you move from right to left, each subsequent place value is 10 times larger than the previous one. 1,000 is 10 times larger than 100. What makes the system work is that you can always trade in 10 of one place value for 1 of the next place value to the left. You kind of already know this if you think about it. For example, 10 tens, you could trade in 10 tens for 100. And that's sort of the foundation of our base 10 value system. I'm just going to look briefly at some other place value systems. This is a base 5 place value system. Notice each numeral to the right is 5 times larger than the previous one. 125 is 5 times larger than 25. 25 is 5 times larger than 5. The numerals we use are 0, 1, 2, 3, and 4 because we can trade in 5 of 1 for 1 of the next place value. Base 2 is the next place value system that we will be looking at. Each digit to the left is 2 times larger than the previous one. 32 is twice as large as 16, etc. We only use 2 digits for this system, a 0 and a 1. Base 16 is also called a hexadecimal system. Each numeral to the left is 16 times larger than the previous one. So it has 15 different numerals it uses. It uses A for 10, B for 11, C for 12, D for 13, etc. F is 15. 16 would be 1, 16, and 0 ones. We're going to look at some commonalities in these base systems. First one we know well, base 10. Notice that 10 to the 0 power is 1. But notice also below that any number except 0 to the 0 power is 1. So 10 to the 0 is 1, 5 to the 0, even 3/4 to the 0 is 1. Now 10 to the first is 10. Notice that any number to the first power is itself. 16 to the first is 16, even 3/4, fractions. So with base 5, the 5 to the 0, that's the ones place. Because any number to the 0 is a ones place, where 5 to the first is 5. 5 squared, of course, is 5 times 5. Base 2 follows the same pattern. 2 to the 0 is 1. 2 to the 1 power is itself, which is 2. Base 16, again, follows the same rule. It's just a mathematical law that 16 to the 0 power is 1, and any number 16 to the first power is itself. We're going to use what we learned and just create a base 7 system, because the patterns are all the same. So the numerals in a base 7 system are going to be 0, 1, 2, 3, 4, 5, and 6. There's no numeral 7 in base 7. There's no numeral 4 in base 5. There's no numeral 10 in base 10. Now, the first place values, assuming we have no decimals, is 1. 7 to the 0 is the same as 1. The next place value will be 7 times that. And we write that with exponents as 7 to the first power. Now notice we have 7 to the 0 power is 7 to the first power, and the pattern is the same. So the next one is going to be 7 to the second power, is 7 to the third power, is 7 to the fourth power. We just put those in. Now to find out what the actual numbers are for each place value, we just note that 7 squared means 7 times 7, which is 49. The next place value to the left is 7 times larger, or 7 times 7 times 7. Which is 343. Now the next place value is 7 times larger than 343, or 7 to the fourth power, which is 7 times 7 times 7 times 7, which is 2401. I'm just going to create a base 7 number. Just make one up, and we're going to translate that into what the number we know in our base 10 system. I'm just going to drop the digits in where they belong. A 1 is in the 7 squared place. There's 3 digits, a 1, a 4, and a 6. Now that's going to mean I have 149. I'm going to add to that 4 7s, which is the same as 4 times 7. And I'm going to add to that 6 1s to find out what this number is, what we know this number as. And so I get 49 plus 28 plus 6. And I add those together, and I would get 83. So 146 base 7 is the same as our number 83. The last thing I'm going to do here, I'm going to count to 10 in base 7. Show you how this works. Think about it. You can pause this tape at any time. So we get 1, 2, 3, 4, 5, 6. There is no 7. There is no numeral 7, so I regroup at 7. A 1, 0 in base 7 is 1, 7, and no 1s. So that's 7. For 8, I would add one more 1. So that's 8, 9, and finally 10. So in base 7, the number 1, 3 is 1, 7, and 3 ones.